Hi everyone. Today we're talking about radian and degree conversions. And these conversions are really going to be helpful for those of you who maybe don't love radians so much. That's like the pies and the fractions and all that. Okay. And I say that because what we're going to talk about today is how to take those radian measures and turn them into degree measures, or vice versa if we needed to. And so if you don't love radians, now you'll have a way to convert it into degrees, and then you can work with it on a circle in degrees. Okay? So in general, the method I'm going to show you here relies on you knowing some equivalency between radians and degrees. So we want to think about some value where we know the radian measure and the degree measure off the top of our head. And I think the easiest one to go with is pi and 180. So pi, when we're measuring in radians, is equivalent to 180 when we're measuring in degrees. And technically this would work with any other combination too. So you could do pi over 2 with 90. You could do 360 with 2 pi. It doesn't really matter, but I think these are the simplest numbers to work with. Okay? And this all relies on you setting up proportions. So I'm going to take the two things that I know are equivalent, so the pi and the 180, stack them up like that, and then I'm setting up another fraction. Okay, and in the other fraction, if I'm given a degree measure, I'm going to put it on the bottom across from the 180. Or if I'm given a radian measure, I'm going to put it on the top across from the radians. So that means that if you're given degrees and you want to convert to radians, you would put your degree measure there and put an x up there for radians. And then we're going to cross multiply. Vice versa if you're looking for degrees. So you could put a radian measure there, put an x here, cross multiply, and solve. Okay? What you're going to find as we go through these in just a minute is that there's some shortcuts. And actually your textbook teaches this all just with the shortcuts. Okay, you're going to see after we do a couple of example ones problems that really you end up just dividing by something every single time. Okay, and I'm okay with you using those shortcuts, but I tend to find that those shortcuts fall out of your brain the fastest. All right, so you may get them now, and when you do tonight's homework, it may be really easy for you to just fly through and divide by whatever every single time. But 2 weeks from now, when you have to take a test, you might not remember the divide by 180 trick. Okay, hopefully you will remember this, because this is pretty mathematically sound. And if you can start with this, then every one of your conversions can just kind of fall into place. Okay, so like I said, I don't mind if you use the shortcuts as you discover them, but just keep this in mind as a strategy to fall back on when and if you forget about those shortcuts, okay? Because the shortcuts require a lot of memorization. Okay, so we'll go ahead and jump into the first one and we can get rid of me now. So for example, this first one, 240 degrees, I'm going to start with pi over 180, always. Because those two things are equivalent. And then I'm going to put the 240 across from the 180 and put an x up top there. And then I'll cross multiply. So when I cross multiply, I end up with 180 times x equals 240 times pi. Now keep your eye on the prize here. Remember, we're looking to find x. So to find that, I'm going to come in and divide by this 180. Okay, so my answer is going to come from this over here. Now remember, if our answer is going to be in radians, it's going to have this pi in it. All right, and it's usually written as a fraction. So I want to take just this, just the 240 over 180, and reduce that like a fraction. Okay, so in my calculator, I'm going to type in 240 divided by 180. There's the decimal equivalent. To turn that into a fraction, I'm going to hit math, fraction, enter, and I get 4 over 3. So this right here is equivalent to 4 over 3, and then I'm going to just drop my pi into my answer, and I end up with 4 pi over 3 as my final answer. And if you think about the location of 240 degrees and the location of 4 pi over 3, you should get that those two things are equivalent. Okay, so I'm going to give you a second right now. You can pause the video if you need to. I want you to work through the 135. Okay, see if you can come up with the number of radians that would be needed to get 135. So like I said, pause it if you need some more time to do that. I imagine that you would. Correct answer for 135 should be 3 pi over 4. Okay, so go back and check your calculation there. Should have come out with 3 pi over 4. I'm going to work through one more with you, but just wanted to see if you could get that one on your own. 780 degrees. We are not changing anything about our methodology here. I know a lot of people are going to want to start subtracting 360 to find out where that's at on the regular unit circle. I don't need to convert this to something smaller than 360 though. I want an angle measurement that's exactly equivalent to 780 degrees. So 780 degrees means that I'm going to spin around the circle once, twice, and then go another, I believe, 60 degrees and land right here. Okay? But I don't want to call that 60 degrees because I didn't turn 60 degrees to get there. Yes, it's in the same position as 60, but I want the radian equivalent of going around 2 full times and then another 60 degrees. Okay, so I'm going to stick with the 780. Don't do anything to the 780 to start. Just start with pi over 180 equals x over 780. That leaves me with, let's see, 180 times x equals 780 times pi. Divide by 180, okay, and hopefully you're starting to see that shortcut that I mentioned. And then it's just a matter of turning this into a simplified fraction. So I'm going to do, 780 divided by 180, math fraction, and I get 13 over 3. And then I'm just going to stick the pi back in my answer, 13 pi over 3. So all the way around the circle would be 6 pi over 3. Okay, just so we're clear here. All the way around the circle, because that's equivalent to 2 pi. All right, so if I go all the way around once, that's 6 pi over 3. All the way around twice would be 12 pi over 3. And then go 1 more pi over 3 and I get 13 pi over 3. And that's equivalent to 780 degrees. Okay, so let's take a look at example 2 now, working with the radians. Just 1 second. I'm still going to start this same way. So I'm going to start with the pi over 180. This time, though, that 5 pi over 3 is going across from, 5 pi over 3. Is going across from the pi. And then this is my x down here, because this is what I'm looking for, is the degree measure. Just like before, I'm going to cross multiply. Now when I cross multiply this time, I get x times pi equals 5 pi over 3 times 180. And the first thing I want you to notice is that there's a pi on both sides of the equal sign, which means that I could start by dividing by pi on both sides, and it's really just going to cancel the pi out on both sides. Okay, so we are really just left with x equals 5 divided by 3 times 180. Okay, so 5 divided by 3 times 180 is 300. And that is my degree measure. Okay? And again, if you think about where 5 pi over 3 is on the circle, it's equivalent to 300 degrees. And yes, you're going to pick up on some shortcuts in here. Okay? You're going to be able to just look at these problems and say, oh, I know that I just do 180 times this fraction. Totally fine, but I would have this to fall back on as a general strategy. Okay? Take a second and again, pause the video if you need to and see if you can convert the negative pi over 6. There is something a little bit tricky about this one. I'll go ahead and get it started. Pi over 180 equals negative pi over 6 over x. Cross multiplication gives me x times pi equals 180 times negative pi over 6. So just like before, I'm going to cross out the pi's, but then you've got this negative sign kind of just floating there. We need to keep in mind that there's really a negative 1 there. All right, so this is really 180 times negative 1 over 6. And that should come out to be negative 30 degrees. And I don't want you to convert that. I don't want you to make it like 330 degrees or anything like that. I want you to leave it at negative 30, okay? Because negative 30 is equivalent to negative pi over 6, okay? And just real quick, if you want to take a second and see if you can convert 10 pi, feel free to pause if you don't want the spoiler here. But 10 pi is going to end up being equivalent to 1800 degrees, okay? That's 5 circles around the circle, okay? Because 2 pi is 1 time around, so that's 5 cycles around. 5 times 360 is 1800, okay? Same thing as if you did this method too, just a shortcut there. Okay, so that's really it for the lesson for today. I do want to take one quick second and mention one thing on the homework. So your homework for tonight is lesson 1010B. And this section here, this very first section, I gave you the hint that you want to be using your calculator, okay? The problem you're going to run into is now you're using sine and cosine with angles that are being measured in radians. Before you put these into your calculator, you have to make sure that your mode is set back to radians, okay? Now, why didn't that matter for what we were just doing? Well, because we weren't doing anything with actual trig, right? We weren't doing sine, cosine, tangent. This only matters if you're actually physically pushing the sine, cosine, or tangent button on your calculator. Anything else you're doing numerically, the mode won't matter. It's just when you use these buttons, okay? So now you should be able to type in sine of 5 pi divided by 9. Look for the pi button on your calculator. On these ones, it's usually above the caret key over here. Enter, and there's your answer. And these are going to be decimals. Nearest thousandth would be 3 decimal places, so 0.985 is the correct answer here. Okay, so all of these can go straight into your calculator. All of these are coming from your unit circle because they're asking for the exact value. And you can either find them on the unit circle using radians, which I'm hoping that you're able to do, or if you really don't like radians, now you could convert these to degrees and then find them on the unit circle. But again, notice the question's asking for cosine or sine or whatever. This is where you want to be using the coordinates, cosine comma sine, and then giving one or the other. Okay, so like square root of 3 over 2, things like that. On the back is where we get into a whole bunch of the conversions. So here's a bunch of convert to radians, convert to degrees. So that's kind of the new stuff we did today. And then there's just some stuff about locating things on the unit circle itself. Okay? But you are doing the entire thing for homework. I know it looks really large, but they're going to go really quickly for you. You're probably going to get to the point where you can just type them straight in. Okay? Good luck. We will spend some time going over this tomorrow.